so the company is called IPython Consulting, and I'll tell you a little bit more about that. It's really not a plug for them, but they enabled me to be here. And if you want to find this talk, at the bottom there's a bit.ly link. I won't track you, don't mind, but don't worry. But it's just PyCon ZA notebook, but I'll give you the link to the GitHub repo a bit later. So what are we going to talk about today? Maybe just some background on the notebook itself, a little bit of plotting, interactive plotting, doing symbolic type maths, touching on pandas. We've used pandas here before. That's super awesome as well. It's almost a drop-in replacement for Excel. Then I'll just show you, I'm not a machine learning guy, so I'm going to show you a pretty neat machine learning example just to give you a feel for the graphics around that. And then to show you how you can publish some of this work. So a lot of the work that I do is doing some interactive work. I'm not a developer, I'm not a coder. My scripts only run once, and then they're done. But I don't have to be pretty. I don't really care what you think about my code. If I get the answer, I'm fine with that. Who am I? I'm an electrical engineer. I'd like to think of myself as a hacker, but I'm probably more of an engineer than a hacker. I don't break everything open I see. I'm very busy with my M, and I use Python quite a bit in my M. I'll show you an example of where we use it. I'm using it to solve some thermodynamic questions regarding hot water storage and production. I'm a principal consultant at IPython Consulting. We're a management consulting firm, so I think the Lloyd's think essentially just a miniature version of that. Some of our clients is City Power. I'm doing a nice job at Ekurhuleni now, which is very data heavy. I'm getting terabytes data sizes sets. I've done some work at Newtel in the good old days. I'm agnostic in terms of platforms. I'm comfortable using Windows. Sorry. Unfortunately, it's a business requirement, and there's some merit in that. Ubuntu on my home PCs and the one in my bar, and I use the Mac for things like this. And then also I use Android and iPhone, so they all have their issues. I prefer some of them to the others, but that's probably not for today. People at my work use Excel a lot, like big time. These guys are addicted to it. They cannot understand this workflow of exploring data and writing it down so that people could change it. Why must you hide it in if statements, drag it down? You want to change the model. I took over a model from my boss, who is a super Excel guru, and I'll never diss him. He's a really, really clever economist, and he's world-renowned for the stuff he does, and he does it solely in Excel. Still a great tool, but every line you have to go through and see what was multiplied. That multiply you can't change somewhere. It's a constant or a variable. You have to go through it. There's 40 of those sheets. And so we transferred it to Python. It worked beautifully, but the company said, we don't like this Python. It sounds silly. And then they read it. It came from Monty Python. I don't know, a bunch of So I'm alone in this journey in my company, but slowly but surely I convinced them to be here. They're buying me a nice server in the next few weeks where we can start doing some of this stuff. And hopefully we'll make small changes from within. This talk's in Python 2.7. A lot of the scientific stuff is only now being fully ported, so I don't really care what Python version I use. For me, the only difference for where I stand is just the brackets in the print statement, really. Okay, Python is popular. You know this. You're going to see slides like this all over the show. We know it's popular. It's being used by everybody. Google, YouTube, Dropbox. A lot of people didn't even know. I think our Dropbox clients in Windows are written in Python. They're busy porting it, I believe. So, yes, it's used everywhere, but practically, one of the uses that I'm using it for is in my M, where we say that water can be stored in a tank, and that tank has some losses in terms of pipe losses. The tank itself, due to its area, has some losses out, and you're also using water from there. You can supply it. Sorry if you can't really see it, but there's a geyser, a solar water heater, and also a heat pump can supply heat into this tank or the system. And if you have a model that represents it, you can calibrate some sort of model, the red line being the model and the blue being the actual. Once you're happy with that, you can take some longer term weather data. This is going to match the PyCon, I think. And you can compare these technologies over a year period. You can see how they perform, and most of that was done in Python and using Matplotlib. So we do use it, and this one, we actually got paid for the work, so that's quite cool. So why would we use Python in data analytics? I'm not sure who here is primarily more interested in data analysis, not necessarily development. Okay, so for us it's important to get a workflow. I mean, Python, a couple of years ago, it was R, mostly R, MATLAB, and those languages. Today Python is really coming through. It's almost like the 100-meter where the third guy or the last horse, it seems to it's going to probably come past soon. So hardcore R guides, nothing wrong with that. These things are tested, tried. Nothing wrong with that. I just find it a bit obscure to use, but I use it every now and then. But Python is multi-purpose. You can use it everywhere. I can use it to do data analysis. If I then want to put that data analysis in a web server, I can do that. There's libraries for everything. I don't know, you saw that joke, the guy that had to write the essay at school, he just said import essay. That was it, okay? It's efficient in terms of code production, so it's easy for us to write code and write it quickly. Performance, not always the quickest. The performance gains in terms of writing it quickly, but with the newer CUDA and NVIDIA graphics cards, being able to talk or Python run code straight on the GPUs and stuff like that is really getting fast, and I'm getting a big NVIDIA CUDA processor for my server, and I'm very happy about that. It's interoperable, so it runs everywhere. I've tested this presentation on all 3 Mac, Windows, and Linux. There's 1 or 2 glitches. It was just libraries that wasn't installed on the other machine, so that's the only issue. And sometimes in the notebook, a couple of the CSS elements not showing properly in the browser. It's interactive, so you'll see today, after this boring bit, we'll do a bit of interactive stuff. And we can collaborate now with Continuum Analytics, we know them. Similar to InThought, awesome 2 companies that's bringing us scientific tools with a one-click installer. Don't have to compile Matplotlib. Don't have to worry about all the independent stuff I can do from my perspective. Some of you would love tinkering in the terminal for hours. Sometimes you just have to get it working. If you, I think it's called Wakari, you can sign up for a free account and have a notebook in the cloud there. The Python science stack obviously consists of Python, which is the base interpreter, NumPy, which is a high-performance array. It was done by the Continuum guys, Oliphant, what's his name? Travis Oliphant. I think it was part of his PhD, still a student, and this thing just took off, because there weren't a high-performance flexible array for Python. You got the SciPy, which is more a stack for regression, optimization, integration, symbolic math, stuff like that. Pandas, which is, for me, the one I use the most, which is time series, which is really, no, not Excel, we're just using Pandas. PyTables, I haven't used that too much, but if your database gets too big, you can do out of memory swapping PyTables. Matplotlib is getting a bit old now, still functional. Everybody uses it, but there's some serious competition. Wired, the guys that's got, they're porting ggplot2. I've used that, and it's really, really awesome. So the R guys have used ggplot2, it's coming. Then IPython, which we're using today. And just to get the full picture, Python is running in the background. IPython is running, and it's connected to this web browser via a kernel, and it's talking a little bit JSON, bobs back and forth. So everything you see here is actually running as a live Python session. I'm not going to talk too much about the IPython. Just in terms of the basics of this notebook. I mean, the notebook itself is awesome. You can do code execution in it, so anything you can run in the terminal, you can run in here. You can type in text, you'll see this is text. You can have mathematics, and mathematics will be rendered. We'll show that the data mathjacks will render your text type stuff for you. Plots, you can have the plots in here, interactive plots. And it's been used at Berkeley, where I think some of this started with Fernando and the guys. They use this to actively teach their programming classes. And since I've done this, it's just a whole mushrooming of everybody's using it. Every single PyCon conference the past 2 years, 80% of the talks were done in an IPython notebook like this. It's also an easy talk to do because visually it's pleasing and people like to see pictures and you can get away with murder. You get code completion, you get access to the help system, you get markdown cells, which this one is. If I double click it for you, you will see this is the markdown of that cell. And if I run it, it renders back into HTML. We'll touch more on this. Cool, some helpful commands. When you in IPython itself, you can use the question mark to bring up IPython's features list. We'll show that now. You can use the percentage quick ref just to get some quick reference. We'll just demonstrate that quickly. You can type help, normally as you would do with any interpreter. And then you can use the object with a question mark, which is very similar to the R object, getting information. A single question mark will bring back the docstring, we'll show that. 2 question marks will bring back the actual function definition if it's available. So we're almost busy, almost at the end of the boarding, but we're going to get a bit more interactive now. So let's get started. Each cell is populated with Markdown or Python code. In this case, you would see it is Markdown. I think I showed it one too early, but again, here's the Markdown for that cell. To run a cell, you press Shift Enter, it will just stay where it is. Control Enter, it will run the next cell. If you press Control MH, you will see the shortcuts you could use. And at any point, even if the kernel is busy or hung, you can press Control S to at least save your. One thing that happened to me yesterday, I used cat and I didn't cat it to a file, and I accidentally catted 800 million lines of text into the cell. So the notebook became about 400 megabytes. In size, I could never open it again. So luckily it's a text file, so you can physically go and remove that. Right, so I'm not sure if you can see this, but this is a typical code cell. I don't assume you're stupid, but this thing has been shown to introductory classes as well. So therefore, we say create and set a variable to form. I know you know this, but if I reuse it, then I don't have to retype it. So basically what it says hello to you, and it just points out the subtle issues in Python about dividing by 0, and that you have to explicitly define a variable as a float, otherwise you'll get an integer back. But the code actually ran in the cell. So using the help system, if you run the percentage quick-ref function with Shift-Enter, you will get a little pop-up screen there that will tell you a little bit more about IPython and some of its functions. Code completion and introspection. So in the next cell, I will just define a stupid 2 functions with a long name. And I'll show you with a question mark how you can get the doc string, and with 2 question marks how you can get the function definition. And I'll show you how the autocomplete function works. So here we define a long, silly dummy name with a doc string, and I think it has some math on it. We then define it again, just giving it a separate name. Once I run this, it will be committed to the namespace. So what I'm just doing at the end here, I'm just looking for the word silly in the namespace. So using the data command, you can get all the functions and variables in the namespace. And I'm just looking for anything with the word silly in it, just to prove that it was actually committed to the current namespace. Cool. So it's found long silly name and long silly name 2 in the namespace, so the code has actually ran. In the next cell, you can type a question mark and see the doc string of that function I defined come in the bottom. It doesn't work for functions that was compiled from Fortran and some other scientific things, but if it's a Python, if the Python.py file is there, you will find it. Then if you use 2 question marks, you would actually get the code that was used to get that specific function, generate that function. Auto-completion also works, so there's almost 2. There you go. So you could, by pressing tab, as you would normally do in the IPython interpreter, you're able to select one of those, or this time it's a function. Okay, and you can also run that function normally in the 5, 6. So it just gives you a bit of an idea of how the interactiveness works here. Can everybody see it? But it's probably a bit blurry. The projector is not that sharp. Using Markdown, I think I've said this a couple of times, you can use a Markdown cell. And basic Markdown, you can define headings, you can even define a table, and I've put some 3 photos, 3 pictures, images inside that table. This becomes very important when you're writing maybe a scientific paper or even a research report. So you would be publishing your whole analysis, all the text, all the work. I've done this once. It looks super awesome. I had custom LaTeX generation, all that stuff, and the client said they wanted it in Word. So, you know, that there's a couple of 4-letter words. So IPython itself has some magics. They call it magic commands. It's probably more like a macro. You can run a magic on a line using a percentage sign, or a cell magic using a double percentage. You can just type in magics and the command, you'll get a list of all of them. One that I will demonstrate that I find handy is the time it magic. I think it's available in any case. But it just shows you how long a piece of code is taking to complete, and it shows you milliseconds per loop. Now the first function, I'm just using, just saying I want to time the next cell, and I'm doing a couple of iterations and taking the power 2 twice. Takes a little bit of time. It tells us 20.3 milliseconds after 10 loops. The best one was number 3. In the next one, I've just removed one of those lines, so it should run a little bit quicker. The weirdest thing, the answer takes longer to come back, but it did take 10.1 milliseconds. We are actively trying to figure out why that is.
Because the second one took 100 loops, the first one took 10 loops.
Cool. So, yes, thank you very much. I don't know how we missed that, but it's still, see, it helps to come to conferences. You can run cell commands. Now, this is not a feature of the notebook itself. You're the guy that did intro math in the previous session. Did you find?
Yeah.
You're the guy.
Yes.
I should have just double checked when you walked in and asked you to leave. You're the type of guy that you want in a presentation. Oh, well done for picking that up. So the good thing about IPython is this whole idea that you can use it as a drop-in cell replacement. I use it as my shell now, and just by appending the exclamation mark in front of a command, you can actually run this shell command. If you're going to run nano or BIM or whatever you use as your text editor, so I just gave away what I use, then you're going to have an issue. So anything that's curses related or something like that, you will have an issue, but you can run your ls and copy and move. I'll show you a quick example of that. In the next snippet, I just create a file list by saying, show me the directory listing in the static image folder. And I just create a dictionary, I just count through them, and I just see, looking at the extension of that file, I'm just counting the extensions. So there's a PowerPoint file in there, sorry, there's a JSON file, some weird DB file that I don't know what it is, one JPEG and a couple of pinks, and that is the images that's actually embedded into the presentation. Embedding images, as part of the markdown, you can embed an image by using the normal HTML image tag, which is not very Pythonic, but you can do that. A bit more Pythonic way would be to use the IPython image function from the display module, and you can display that image like that as well. You can add a YouTube video. So similar, you would import the YouTube video, and if I'm connected now, this is one of Fernando, the guy that created this, one of his first IPython talks. I'm not going to press play now. Cool, so plotting, I think that's where it starts getting a bit more interactive. So in versions up to number 1 of Python, there were no real room for interactive plotting. That's changed, and I'll show you some of the static plots in terms of matplotlib, and then we'll get into a bit more interactive. There's one or two what we call crowd pleasers at the end. This is a simple function. I don't have to really go through it in detail, but we create an array, and then we distribute some numbers in that array, and we plot, we scatter it, do a bar chart, I think it's even a line chart. So just that piece of that snippet would actually create interactive those plots. Another example would be that you can combine plots. So the next code snippet would create 2 plots, and it would combine it. And you would have a plot within a plot. This one just zooming in around the origin there to show you what's going on there. You would see, and I'll show a bit more of that, you can use the LaTeX type markup, and it would then render that math as mathjax. Not mathjax, it would be rendered properly on the image itself. We can add text to a plot. Again, probably similar to the previous one. And by changing the font size, probably make it a bit bigger. Let's make it 500, I want to see what happens. Right, so it didn't actually make the text bigger, it made the plot smaller. Okay, but interactive, I think that's the proof. I mean, interactively you can play with these things and you don't have to redo a lot of it. I don't know, some weird dude, there's always a dude. There's always that guy that would like to just port everything, and there's also now an XKCD plotting style available to matplotlib. So here's a little bit of a code snippet that creates the following 2 plots, and you only have to we just have to say with plot.xkcd, and then just transform it. So, did I run it now? So like I said, there's always that guy. So the first part is really just saying that his overall health compared to the day he realized that you could cook bacon whenever you wanted. It's happened to many of us. And then this one is quite interesting. The claims of supernatural powers confirmed, and shoot at the experiment. Quite interesting that now that we have cell phone devices all over the world, there's very little photos of UFOs coming through. You know, in the old days, they were everywhere, now they're nowhere. Symbolic math. Who uses symbolic math? You're studying still. Something you probably use a little more when you're studying. Or you're trying to show people fancy equations. I do that when I'm in a bar on my own. I take a napkin and I write integral and stuff like that. I don't know what they do, but I hope people think I'm clever. And I really do that. I mean, it's not a joke. So here you would define and expand the exponential function in its series. It even does a little bit of the O notation. You could also define an equation that would be x plus y to the power of 2 times x plus 1. And if you just want to pretty print that, you can just have a look at what that looks like. So that will show you nicely what that looks like. You can also ask you to solve that. There's something wrong with my formatter, but at least it gives you the answers. I tried to do special formatting for the presentation, and I think I broke it. But anyways, the answer of that is x minus 1 and x minus y. Here's another function, something I stole from the internet, like most of the presentation. You can simplify that, and it simplifies it. Sometimes doing that by hand is just a labour's task, except to you. You are probably the lookup table that is on the internet that this searches for. All right, you can ask it to integrate x to the power of 2 times the exponent of x times cos of x over x. This takes a while, even for you, sir. Takes about 5 or 6 seconds. But that is quite a difficult one to integrate. You would have to look at tables and stuff like that. You see what the answer is. It's quite a heavy thing. Okay, so pandas. So we all love pandas. Where's McKinney there? Where's this guy that works in finance? I think he got frustrated with Excel. Just keep on breaking with larger data sets and not being vectorized. For those of you that work with large sets of data, vectorization means that you don't have to. In the old days, we would actually iterate over an array and then in line change every single value, index it. Remember Pascal? For I equals 10, then the array index it, and then get the value, answer it, and then write it back. Now you just say array times 2, and it knows it just needs to multiply every single value with that. So what pandas does is really gives us that. It's a 1 and a 2-dimensional array. They've added a panel so you can do 3 and 4-dimensional data with it. But I struggle to think a lot further than 3 dimensions, and you should too. So for us, the data frame is really a drop-in replacement for the R data frame. Who's R here? So R data frame is the thing. If R didn't have the data frame, R would be dead. But the most powerful thing in R is that awesome data frame. You can do some awesome stuff with it. And this is Python's way of trying to get into that playing field. And it's doing it very, very well. And I believe it's fast, but I'm not going to get into that debate now. So, a quick example of pandas. What I'm going to do here is I'm going to read into a data frame, a CSV file that has all the Cape Town 2009 min and max temperatures and some solar radiation. And then I'm just going to show you the head, the first 10 entries. Okay, so just read a CSV file. We put it in a data frame. The data frame is now accessible, and you can do a lot of awesome stuff with it. And I'll show you a couple of those things now. You can plot it. So just by calling that variable and the high.plot and the cape weather.low.plot, you can plot the values in there. So it's really easy. You don't have to physically know what's in the data. You would see that it is indexed with a dot notation, but nothing stops you from putting square brackets and putting it as text when you have spaces. You cannot do that because people will give you data with spaces in the name, because they don't know that you want to do this. And people love spaces. File names everywhere, they just want to put spaces. Underscores are, I don't know, it just seems in conferences like this, people are comfortable using an underscore. In real life, people are really scared of the underscore. All right, so that data file that I read in, the first 2 lines had 365 values for the year. The third column only had 12 values, which was the mean radiation for each month. And what I'm going to do there is I'm just going to plot radiation, but only the first 12 values, just to show you some indexing on the data frame as well, which give us the mean solar radiation in Cape Town. So just a question, and it's quite interesting. What city in South Africa has the lowest mean solar radiation per year? I'll give you options. Durban, Joburg, Cape Town. Okay. You said Durban. R100. Okay, so it's Durban because it's hot there, it's humid there, there's a lot of cloud cover all the time, so the solar radiation is an issue. So just from the research perspective, the heat pump works very, very well in Durban because of ambient temperature. It works very, very well in summer here, but not in winter because we have low ambient temperatures in winter. But we have massive, very high radiation. So solar water heaters are a bit more friendly here, except we have a lot of hail, which is another issue. All right, so if you want to query that data frame, what I'm going to just look for, this becomes important. I don't know if some of you have been in HVAC or for 10 minutes. You want to just have a look at how many days you have more than 25 degrees and less than 25 degrees. Here we go look at the data set. We say Cape Town weather, where Cape Town weather high is higher than the level. Count that for me and show me the results. So that would show me that there's 59 days that is warmer than 35, which makes Cape Town really a shitty place to stay. And I'm from Cape Town, so I've been on both sides. It's awesome to go there. Waterfront's great, all the other places, but there is the mountain on your left and you come back. Then you can do basic statistics on this. You can describe it, and you would see that there are 365 values in the high and the low, and you have 12 values in the radiation with its mean, standard deviation, its minimum, and some of the bins. This is actually quite cool. You can run a SQL query using SQLite on this data frame. So you could say there's a helper function that just looks at globals. So from the globals, it will just look at where's the data frames, and you run this query. You could say select the count of the high, call it count. What is high minus low, call it t-spread. From the weather, you just call it whatever the variable name is. You would go and find it. And you would say where it's higher than 25 and lower than 10 and show that to me. So there's 3 days with a large temperature spread in Cape Town. That also becomes important for some guys designing air conditions. Just an example of a box plot or histogram. Type settings on the tag. I'm just going to show you one or two so you could review it written from the tag. So let's vote. Latte, lit tag.
Latex.
Latex? All right, you see why we just say we print some math. Okay? So it would render that. So what's happened here is it would render it, send it to MathJax would render it and send it back to the browser. Here's one that I draw on the napkin. I don't know what the hell this is. It really looks awesome. There's some cross products in there, all that stuff. Can you please tell us what that is?
I'm actually not sure.
Wait, that's also the question.
Then you can save this whole thing as you can save it in pastebin. So just saying pastebin cell 1, I call it cell 1, 0 to 10. If you go to that URL now, you'll find the first 10 cells values in there. Now move on quickly. You can connect to this kernel remotely. If you're on the same network than me and you type in this information, you'll be able to get into this kernel. It's not secure at the moment. You'll be able to inject code into the kernel. Please don't. Then interactivity. I think this is where it's a little bit better. What this code does is this, I don't know who here works with networks, network representation, social media analysis. You get a couple of views, lobsters and clusters and Ardos, Renu, Newman, Watts, all these type of network generators. And if you wanted to draw one of them, you have to physically go and draw it, and you have to put in the parameters that you want at that specific time. So that's silly, because every time you want to change it, you're going to have to go and rerun that function. So from IPython 2, I believe, they've added this interact function that just wrap that function that you created, and you provide some limits to it. Let me show you what the output of that is. So we can change here, and you can change even the generator that it used. So it gives you a little bit more of the, let's call it the Python after Excel pivot table-y type interactivity if you really have to impress your boss. I think there's another one. So this one just draws some random scatters, and you can change the size, change the color, and let's see if we're not. You can link to other, and this is actually the nicer one to show. You can link to other notebooks. This one shows the Lorentz differential equations. I used to know them a while back, but it was a very, very long time ago, and it was only for one day. That's the day you write the exam on it. But to solve this is really heady. Python really solves this relatively easy using numerical methods. And again, if you want to plot it, it will give you a plot. But again, there's angles and some steps involved. And again, if you wrap it into interactive, this one really leads itself to some really cool visualization. You can change some of the parameters. It was very, very difficult when you study this, is looking at a 3D. And this is really when you start spinning it around its axis. It really becomes very cool. The first time this was shown at PyCon 2012, people were on their chairs clapping. It was something really new for the Python community. MATLAB has had that for years apparently. So just a quick machine learning example. The next bit of code just generates some random data. I wanted to show it to you like this actually. So I'm not solving it, I'm just generating two sets of random data, and you will see there's this blue blob with some of the residuals scattered around the red blob and the red blob and the red stuff. So you want a machine learning algorithm that will be able to figure that out. The one that is used here is called AdaBoost. AdaBoost was developed by, I think, NASA, some of the guys there. No, the guys that's looking for the quarks and stuff, what do you call it again? CERN. So guys at CERN, as part of the, just before the Large Hadron Collider, the smaller one, which is actually quite pretty big as well. They developed this one. And if I just add solve there, it's pretty crude. Then what the machine learning algorithm would do, and this is actually very neat, it actually chunked out. Just looking at the data, I found the pattern in there. It's not without errors, but incredible that it could actually do that. So from machine learning, moves into pattern recognition, which is the old name for it. Love to speak to you more. It's a field that I really like, but I don't know too much about it. Do very basic pattern matching. It used to be pattern matching, yeah? Now it's machine learning. It's a lot cooler, and you get jobs when you say that. All right, if you want to publish your work, just finishing up quickly. If you run this command, IPython nbconvert, you can say, put it to slides for me and serve it. What it would do, it would convert this whole notebook, hopefully, into presentation. Open up a browser, and now it's more of a static revealed.js type presentation. Just be careful not to, at the end, embed itself on itself. So you can embed a web page, you can embed it, it does that for 4 iterations, and then it complains. So most of the stuff would be there. Cool. The next one does the same, it just serves it as pure HTML. What's happened now, the kernel is now locked, so I have to go out and kill the kernel. So I can't run this at the moment, but it just serves you pure HTML. Right, so people are writing books, just finishing up, people are writing books, and if you want to see a really cool example, you can go and have a look at probabilistic programming and Bayesian methods for actually a proper full book that's been written in Python and the notebook. Thank you, so thank you for your time. If you want to find out more, all of this is there by that Bitly link. Please join us at the Gauteng Python user group. Myself, I think the same would be Walter Wasbier. He's here, we do get together every now and then, have a couple of Python courses. We're on Meetup there. We have Google groups there. We have a website there. We're on GitHub. We've made sure we're everywhere before we came here. And then we do a Python course. It's not non-profit. We ask a small fee for a day for Python introduction. There's one for Python data analysis. We would do some of this. And we work on a Python for kids. One, we had some interest. We're just waiting for one or two schools, and you can find more there. Thank you.